Hi calculus, welcome back. In this video, I'm going to talk to you about the chain rule using Leibniz notation. Leibniz was someone else who worked on developing calculus at the same time that Newton was developing calculus, and there's actually a lot of really interesting math fights and debates about who came up with which idea first and who has the better notation. Sometimes in math, you'll hear people say that, Leibniz has a better treatment or Newton has a better treatment for a particular topic. That just means that the notation and the way in which you think about it is better, more useful. Just basically shorthand of saying better mathematics. So fascinating math history there. If you're bored, go through those Wikipedia pages and see what you can figure out. All right. So here is the chain rule, but just with a little bit of different notation. So we're saying if y is a function of u and u is a function of x, then when I take the derivative of y with respect to x, that's going to be the product of the derivative of y with respect to u and the derivative of u with respect to x. And I think the best way to do this is by an example, because by now we're starting to get practice with the chain rule. We're starting to get it. And so let's talk about all these u's and x's and things here. So let's use this notation and find the derivative of y is equal to x over 3x plus 2 to the 5th power. So here we've been looking at inside and outside functions, and we're going to do the same thing using this notation. It's just a switch up of how we look at it. This notation, by the way, is really common in physics. So those of you who are physics buffs out there, you really want to practice this notation. So this is what we're going to call u. We're going to say, oops, I spent all that time coloring it in so pretty. We're going to say our function u is equal to x over 3x plus 2. And then now that means that if this x over 3x plus 2 is equal to u, then now we could say that y is equal to u to the 5th. So just like before, we were thinking of inside and outside functions. What we're doing here is we're using substitution, and we're naming that inside function u. So we need to know the derivative of u with respect to x. And we need to know the derivative of y with respect to u. Okay. So the derivative of y with respect to u is not so bad, because we just have a chance to use our power rule. So it's going to be 5u to the 4th power. And because at the end of the day, we want to have all of our variables back in x's and y's, we're going to undo that substitution. U is just this function, x over 3x plus 2. So this will be 5 times x over 3x plus 2 to the 4th power. And that's because this right here is our u function. Okay? So now we know the derivative of y with respect to u. The next thing we have to do is take the derivative of u with respect to x. So in that notation, we have derivative of u with respect to x, and we're going to use the quotient rule here. I almost want to show you guys my workaround and how I use the chain rule to do quotients, but I think that might be too much in this particular example, so I'm holding myself back. I hope you're proud. So the quotient rule tells us that what we're going to do is take the denominator and leave it alone. 3x plus 2. Leave it alone. Take the derivative of the numerator and multiply it. Then we're going to subtract the numerator, but leaving it alone. And then take the derivative of the denominator and multiply it. And that's all over the denominator squared. So let's do some simplifying. This gives us 3x plus 2 minus 3x all over 3x plus 2 quantity squared. I have a positive 3x and a negative 3x, so those add up to 0. And I'm left with 2 over 3x plus 2 quantity squared. So now I know what is dy, and I know what is du dx. So I'm going to take these pieces and multiply them in. So together, because what the chain rule tells us is that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So here's my derivative, dy dx. So this is my derivative of y with respect to u. So I have 5 times x over 3x plus 2 to the 4th power. So that's my derivative of y with respect to u. Then I'm going to multiply in the derivative of u with respect to x, which is right here. So I have, oops, I don't have equals there. Hey, Sarah. All right. So I'm going to multiply in that derivative, 2 over 3x plus 2. And then down here, that's squared. And all that's left for me to do is some multiplying and some simplifying here. So then we have dy over dx is equal to 5. I'm going to use my laws of exponents to say that this is 5 times x to the 4th over 3x plus 2 to the 4th power times 2 over 3x plus 2 squared. And because I have all these fractions I'm multiplying here and here, I'm going to look at 5 as a fraction too, 5 over 1. So when I'm multiplying fractions, I multiply numerators and denominators straight across. So that means I take this product here to get 10x to the 4th, and then this product here. Ooh, I made a mistake, guys. Can you see it? That's a 2. That's a 4. This is supposed to be a 4. 4. So then my denominator, the product, should be 3x plus 2 to the 6th power. And that's my final derivative. Some of you might like this a lot better than the function notation. It's fine to have a preference, but I think I mentioned that this is a very popular notation in physics. So if you're a physics person, you should practice this notation. And you can use it anytime you use the chain rule. That's fine with me. In your homework, I want you to do at least 2 or 3 using this notation. And if you're a physics person, you might want to try all of them in that notation. All right, I'm going to give us another example here. Just because the chain rule, we could always use more stuff. So let's find the derivative of y is equal to the tangent of 4x squared minus 3x plus 1. So for this, I'm going to say that u is my function inside, 4x squared minus 3x plus 1, and that y is equal to tangent of u, and that's what we're going to take the derivatives of. So first we'll do our u. Our derivative of u with respect to x is equal to 8x minus 3. Now for this one, you'll need to remember what the derivative of tangent is. It's okay to look it up, but it's worthwhile for you to memorize it. So hopefully at this point, you know the derivative of y with respect to u would be secant squared of u. And because at the end of the day, we want this to be a derivative that's defined in x, we're going to go ahead and undo that u substitution that we did here. So what is u? U is equal to 4x squared minus 3x plus 1. So we're going to put that right back in there. So this is equal to secant squared of 4x squared minus 3x plus 1. Beautiful. Now we're ready to go ahead and use our chain rule, which tells us that the derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. So our derivative of y with respect to u is right here. And when we did our substitution, we got this. So that's secant squared 4x squared minus 3x plus 1. And our derivative of u with respect to x is 8x minus 3. You guys could probably do a drinking game at this point by how many times I try to use a highlighter, but instead just scribble over it. Please don't, though. It's not good for you. You got to find healthy coping strategies during this difficult time. Healthy coping strategies are not playing drinking games with your online classes. That would be an example of an unhealthy coping strategy. It's okay if you guys are feeling overwhelmed, by the way. If you're feeling overwhelmed, if you miss class, if you're frustrated, that's all normal. And just try to take a deep breath. Be patient and kind with yourself, all right? You know that we all deserve a break, given how crazy things are. And if math is causing you stress, please reach out and shoot me an email and let me know that you're struggling with the material, and I'll do my best to help you. Realistically, we're all going to need to do a lot of review in our next classes. This experience, this is our final answer, by the way, is not the same as taking a class in Calculus 1. And so your Calculus 2 teacher, whoever that may be, I hope I'm lucky enough to be that person, will have to be patient and give you lots of review of Calc 1 material and help you along the way. All right, that's the end of my digression. I really want you guys to be well. Be well. Stay safe. Just by watching this video,